So today, for the core math chapter 2 series, mixed exercise. So a lot of questions. So I may skip some of the questions, but I'll focus on the red questions. So number 1, express in partial fractions. So 2 over x, r plus 2 and r plus 4. So this may be separate with the denominator of r plus 2 and r plus 4. So r plus 2 and b over r plus 4. So we cannot go from here. That's why we set it on the right side, because we will go back here again. So now we make the common denominator again, r plus 2 and r plus 4. Then a should be multiplied by r plus 4 plus b r plus 2. So because I just write it again, like a rewrite on the left of the left side to the right side. So this and this is identical. So now we have same denominator, so we need to have the same numerator. So 2 becomes a r plus 4 plus b r plus 2. When it says identical, means this is identity. Whichever is the number of r, this is always true. So if r equals negative 2, then a becomes 1. Ooh. If r becomes negative 4, a becomes negative, b becomes negative 1. So now we found the partial fraction of this one. So 1 over r plus 2 minus 1 over r plus 4. So hence show that from here. So let's start with r equals 1. So 3 plus, 5 plus 1 over, now 2, 4 plus 1 minus 1 over 6 plus 1 over 5. Now r equals 3 minus 1 over 7 plus 1 over 6 minus 1 over 8 plus blah 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 plus. I want to check the patterns of this elimination. So just to make sure how many terms I need to write down on the at the end. So here, so we eliminate this 1 over 5 together and 1 over 6 together, and maybe 1 over 7 from behind and further behind. So means we still have remains of the first two terms. From the first two terms means we need to have the remains of last two terms also. So let me put n minus 1, then n plus 1, 1 over n plus 1, and 1 over n plus 3, plus now n, 1 over n plus 2 minus 1 over n plus 4. So let's say, so elimination again. So let me change the color. So this and this, this and this, this and this, this and this. Let's say like this. Anyway, because this is the pattern. So now we have 1 over 3, 1 over 4, minus 1 over n plus 3, minus 1 over n plus 4. So now we have all of this, and when we make them all the common denominator, 1 over 3, 1 over 4, n plus 3, n plus 4, then 12, n plus 3, n plus 4. So first fraction has only 3, so we need 4 and n plus 3, n plus 4. Just to reduce the time, just let me expand it as I wrote down. 7n plus 12 plus 4. 4 need 3 and n plus 3, and n plus 4. So 3 n squared plus 7n plus 12 minus, now we already have n plus 3, so we need 12 and n plus 4. So 12n minus 48 minus, we have n plus 4 already, so we need this one. So 12n minus 36. So 12 n plus 3, n plus 4, we have 7n squared plus 49n minus 24n plus 25n. So now 84. So 84, and this is 84. So the constant, we don't have any constant term. So this is exactly same with this. So the next one. Partial fraction again. So I think A and B is repeated with the first question. So I will do only number C. And with assuming I already go through of the A and B. So now I know this is the result of these differences. So on the left side and on the right side are same. So here, this starts from number 1, r equals 1, but now we need to start from r equals 100. Means, actually this is, we can start with r equals 1 because this is the equation, I mean the formula when we start with r equals 1. That's the problem. So we start with r equals 1 to 200. 4 over 4r minus 1, 4r plus 3. And now we have when r equals 1, r equals 2, r equals 3, blah, 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 r equals 200. But we don't need from r equals 1 to r equals 99. So let's eliminate it. R equals 1 to r equals 99. 4 over 4r minus 1, 4r plus 3. So now we can use this formula because we already have the result. So this, because this has variable of n only. So now we have 4 and 200 over 3 and 4, 803 minus 4 and 99 and 3, 400, 399, like this. So when we oh my god, I don't have my calculator. So when you calculate it, you may have the result. Number 3, show that. So yeah, because you know already the binomial expansion, so we know this, the coefficient could be 1, 3, 3, 1. So r cubed, 3r squared, 3r plus 1 minus r cubed minus, because this, I mean the second one is, let's say 3 and r squared and negative 1 plus 3 r negative 1 squared plus negative 1 cube, like this. So we don't have r cubed anymore. So now we have negative 3r squared with negative sign outside of the bracket. So now we have 6r squared. And this one 3r squared and minus 3r squared, we have 3r squared, so we don't have it anymore. So my 1 minus minus 1, so plus 2. So using this result, and we need to show that this one. Oh, okay. So r squared. Maybe because we need to use that, so sigma r equals 1 to n, r squared maybe r plus 1 cube minus r minus 1 cube minus 2 over 6, like this. I just make the r squared as a subject. So let's just take out 1 over 6. And let's put the numbers from the beginning. So when r equals 1, so 2 cube, 0 cube, minus 2, plus r equals 2, 3 cube, 1 cube, minus 2, plus what is that? This is r equals 1, 2, and 3. So 4 cube, minus 2 cube, minus 2, blah, blah, blah. But now we need to understand the pattern of the first part. So now we eliminate 2. Okay. So now we can eliminate, like this is like after 2, how can I say? So it is not next by next, side by side. It is one further side. So we eliminate 2 cube, 3 cube, and blah, blah, blah. So means we need the last 2 parts to fit the pattern. So n minus 1. So n minus 1 means n cube minus n minus 2 cube minus 2 plus now n plus 1 cube minus n minus 1 cube minus 2. So let's delete it again. So 2 and 4 can delete maybe here, something like that. So the first, we delete the term 2 cube, 3 cube. And the last 2 parts, we need to delete the middle terms. So now we have 1 over 6. Yeah, let's remove 0. And negative 2, we have n of negative 2. So negative 2n. And now we have here 1 cube minus 1 and plus n3 plus n minus n plus 1, 3. N cube, 3n squared, 3n plus 1. So we don't have 1 anymore. Oh, it's good. So now 1 over 6, 2n cube, 3n squared, plus n. That's why. So let's take out n. 2n squared, 3n plus 1. N over 6, 2n plus 1, n plus 1. So QED. So number 4. This is the one, I think this is just, we can do that with the partial fraction again, like number 1. So you can do that. And number 5, this is the very similar what I did just now, because this is again, actually I call it ping pong. Yeah, because we can eliminate after a few terms. So you can eliminate each of them and something like that. So let's do that. So we start from n. So n plus 1 cube minus n minus 1 cube. You know, actually the easier way is better to make the smaller number front. Just for me, I'm a little bit confusing when the larger number comes first. So let me just make it like this, plus r plus 1 cube. So when r equals n, negative n minus 1 cube plus n plus 1 cube plus negative n cube plus n plus 2 cube plus n plus 1 negative cube plus n plus 3 cube. Am I correct? Plus blah blah blah. Let's see the pattern again. So here n plus 1, n plus 1. So this will be eliminated with the further term. So means they have no pairs to be eliminated together. So again, we need two last part. So plus 2n minus 1 and 2n. So when 2n minus 1, 2n minus 2 cube plus 2n cube plus negative 2n minus 1 cube plus 2n plus 1 cube. So like this. So again, the front term, we need to eliminate the larger number. So now we eliminate the smaller number like this. So now we have negative n minus 1 cube. So n cubed minus 3n squared plus 3n minus 1 plus minus n cube plus 2n cube, 8n cube plus 8n cube and 4 and 3, 12n squared. You can follow the binomial expansion 6n plus 1. So now we have 6n cube. Oh no, so here, 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 and here. So not 6, actually 14. 14n cube and plus 3 plus 12, 15n squared plus 3n plus 2. I think this could be the answer. You need to understand, I of course I may have some mistakes because I don't check any answers, so please check the answers first. And write down Maclaurin series of cos 4x, including write down means you already know the answers and means you have the formula booklet. Just let me find some formula booklets. For A level for the math. So here, cos 4. You know, this Maclaurin series is so interesting because it's very flexible. If you know cos x, then you will know cos 4x because then cos 4x, they are just like composite functions. So if you know cos x, then just you can put 4x into all x. So from here, the formula booklet, I can see cos x equals 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial, blah, 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 like this. So here up to including term in x to the power of 6. Okay, so now cos 4x becomes 1 minus 4x squared over 2 factorial 4x to the power of 4 factorial 4x to the power of 6 over 6 factorial plus blah blah blah, like this. So this is the answer. And if you make it like a calculate, as I mentioned, I have no calculator now. So when you simplify it, you will find out. So hence or otherwise, so that the first two zero terms, okay. So now we need to use the trigonometry identities. Because cos double angle identity has the sine square of 2x. So cos 4x becomes 1 minus 2 sine squared of 2x, because we know the cosine double angle identity already. So sine squared of 2x becomes 1 minus cos 4x over 2. So 1 over 2, 1 minus 1 plus 4x squared over 2 factorial minus 4x to the power of 4 over 4 factorial plus 4x to the power of 6 over 6 factorial, blah, blah, blah. So when you simplify this, this is the answer. Maybe this is this one. Okay, and number 9, given in x to the power of 5 and higher powers may be neglected. Okay, means we can find until x the degree 4. Use the Maclaurin series of e of x and cos x to show that. Okay, so e to the power of x and e to the power and cos x we already have on the formula booklet. So e to the power of cos x means 1 plus instead of x we just put cos x, which cannot be the answer. Cos x squared over 2 factorial and cos x to the power of because I just think of something, because here we take it out x, so maybe it's better to make it like this. So here 2 to the power, because here I already used that one, so 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial minus blah blah blah. I don't need the power of 6 anyway. So here e to the power e, because now we know exponential rule. So and e negative x squared over 2 factorial plus e what is plus, sorry, times e x to the power of 4 factorial, blah blah blah. Then e from the formula of the Maclaurin series of e, 1 plus e to the negative x squared over 2 plus negative x squared over 2 squared over 2 plus blah blah blah. We don't need any further. And here 1 plus x to the power of 4 and 4 factorial plus blah blah blah. We don't need any further. So now here, anyway, we need only until x to the power of 4. So e, the constant term comes from here on both sides, so we have only 1 plus we cannot have the term in x, so now we can have x squared here like this. So negative 2 x squared over 2 plus and x to the power of 4, so like here, so x to the power of 4 over 4 factorial, and here when they meet together here, that is the 8 in the denominator and x to the power of 4 plus blah blah blah. E 1 minus x squared over 2 plus 4 factorial is 4, 3, 2, 1, 24. So 24 and here 20 and 3, 4, x to the power of 4, blah, blah, blah. So now this is the answer. So yeah, as I mentioned, Maclaurin series is really the flexible within like near 0, of course. So when you see like this composite the expressions, then just you can put the numbers there. So even this one, because you already know sine x, the Maclaurin series of sine x, so you can put 2x and you can square it. But just I want to show you to use this cos 4x So now number 10, given. So now number 10, I'll just give you some touches. So ln, so now this is a log, so we can use the law of log. So ln 1 plus x squared plus ln 1 minus 2x becomes 2 ln 1 plus x plus ln 1 minus 2x. 2, 1 plus x, x minus x squared of 2 plus x cubed over 3 plus blah blah blah. And plus negative 2x minus negative 2x squared over 2 plus negative 2x cubed over 2 plus 3 blah blah blah. So here 2x and negative 2x. Oh my god, we don't have x term. And x squared. So now we have negative x squared. And what is that? 2x squared. Negative 2x squared. This one, 4x squared over 2. So negative 2x squared. Plus 2 over 3x cubed. And here, negative 8x cubed over 3. So equals negative 3x squared minus 2x cubed. This is the ascending power of x for this answer. And number 11. Ascending power of x up to, okay, so this one we need to really calculate it. So let's do that. Number 11. So ln secant x plus tangent x. So let's find the first derivative. Let's call this y. Then y prime equals yeah, let's do it here. Okay. So y prime, this is nice. Let's delete everything. So y equals ln secant x plus tan x. So y prime, this is chain rule. So sec x plus tan x on the denominator, because this is log. So ln, derivative of ln is 1 over x. ln x is 1 over x. So now we need to do this chain rule. The secant x becomes secant x tan x plus the secant squared x. Oh, okay. So secant x tan x plus secant x over secant x plus tangent x. So now we have only secant x. Yeah. And y squared, a double derivative. Then secant of x prime is secant of x, tangent of x, including x. So we need to do one more further. So now this is the product rule. So secant of x times secant of square root of x plus secant of x tangent of x times tangent of x. So tangent square root of x, like this. So this is Maclaurin series. So we need to put 0 into x. So here, when x equals 0, y it becomes secant of 0 is 1, tangent of 0 is 0. So ln 1 becomes 0. So x0 is 1. x0 becomes 0, x0 becomes 1. So you can see from this formula booklet about Magnolia series how you can compose it. So f of x becomes f0 plus x f prime of 0 plus x squared over 2 factorial times f double prime of 0, which is 0 for x, plus x cubed over 3 factorial times the triple prime of x of y, so it becomes 1, plus blah blah blah. So x plus x cubed over 6 plus blah blah blah. So this could be the answer. And let's go further. Number 13. Given this one and show that this one. Okay. So here, yeah. Oh, everything is so long way to go. So I need more space. So here, cos and sec, we know they are like a reciprocal relation. So cos x times secant of x becomes 1. That's what we know. And cos x is given 1 minus x squared of 2 factorial plus x to the power of 4 over 4 factorial plus blah blah blah. And secant of x we don't know because this is show that question. So the result should be shown. And we cannot use the result from the solution. So here, I just want to put 0, a0 plus a1x plus a2x squared plus blah blah. This is x, a3x. Oops, sorry. a3x3 a4x4 plus blah 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 equals 0. No, I mean 1. So let's make the constant term on the left side is 0 equals 1. So now we know a0 is 1. So let's make x1 term, x term. X term is a1x becomes 0 because we don't have any x term on the right side. Means a1 equals 0. X squared term like this. So a0 times negative 1 over 2 factorial x squared plus like this a0 x squared should a2 x squared, sorry, should be 0. So now we know a0 equals 1. So negative 1 over 2 plus a2 becomes 1 as 0. So a2 is 1 over 2. So now we know 2 of them. And let's go for the x cube. And x cube like this one and this one. No more. So here a1, negative a1 2 factorial x cube plus a3 x cube becomes 0, but we know already this is 0 because a1 is 0, so a3 becomes 0. So a4 now x to the degree 4, so this one and this one and this one make x to the power of 4 term. So the first one is a4 plus second one negative 2 factorial a2 plus 1 over 4 factorial a0 x to the power of 4 becomes 0. So now a4 we don't know, a2 is 1 over 2, so negative 1 over 4, plus 1 over 24 becomes 0. Therefore, a4, this is 24, 6, 5 over 24. So now we know a4, a3, a2, a1, a0. So therefore, secant of x becomes 1 plus 1 over 2x plus 5 over 24x to the power of 4 plus blah blah blah. So using the result found in part A, so now we show that and sine of x, we know sine of x. So now we know cos of x, secant of x, sine of x. And it asks us to show first three non-zero terms in the series ascending power. Tangent of x, okay. So, so now we know tangent of x is sine x over cos x. So sine x is x minus x cubed over 3 factorial plus x to the power of 4 over 5 factorial plus blah blah blah. We don't do over, you know, because the Maclaurin series is the polynomial series. So if we make it here, then it's very difficult to make it as a polynomial. This is just the infinite rational series. I don't know whether we have the kind of expression, but anyway, it is not our purpose. So Maclaurin series, we always need to make it as a polynomial term. So from the previous question, the e to the power of cos x. So I wrote it down like 1 plus cos x plus blah blah blah, something like that. And I kept murmuring like, oh, this doesn't work, blah blah blah, because it was expressed with cos x, not like polynomial term. So anyway, so we need to make it as a polynomial. So now this is, we know sine of x, and instead of over cosine x, anyway, over cos x is secant of x. So now here, secant of x, 1 plus x squared over 2, 5 over 24 x to the power of 4 plus blah blah blah. So first three non-zero term. So now there is no constant term of this expansion. So now we have x term of x. We don't have x squared. So now we have x to the power of 3. So minus x to the power of 3 minus 1 over 6 plus 1 over 2. And we cannot make any x to the power of 4, but we can make x to the power of 5. X to the power of 5. So here 5 over 24. Here negative 12, 1 over 12. Here 1 over 120 plus blah blah blah. So x 6 is 3, 2 over 6, 1 over 3, x cubed. 120, 25, 10 plus 1, then 16, 120, then 2 over 15, x to the power of 5, plus blah blah blah. Please check the answers. So anyway, the way of solving could be correct. Just you can check the correct answer once more. And number 14, expansion of e to the power of x cos 3x. Yeah, it's the same. Just I'll just give you some hint and you will solve it out. So e to the power of x from the booklet, 1 plus x squared over 2 factorial plus blah blah blah. Cos 3x, cos x and we with 3x. 1 minus 2 factorial 3x squared plus 3x to the power of 4 over 4 factorial plus blah blah blah. So actually we don't need this because up to x cubed. So anyway, so here you can expand it step by step from the constant term, x squared term, blah blah blah, like this. Then you will find out. And the next one, 15. Find the first three derivative of find expansion. Expand 1 plus sine x and hence the approximate. Okay, let's go with number 15 first. 1 plus x squared ln 1 plus x. So let's call this y. 1 plus x squared ln 1 plus x. So y prime is 2 1 plus x times ln 1 plus x plus 1 plus x squared over 1 plus x. So 1 plus x means 1 plus x into ln 1 plus x plus 1. And y double prime, this is 1, so 2 ln 1 plus, I'm just applying the product rule continuously, plus 1 plus x and 1 plus x, 2 over 1 plus x plus 0. So this is 2. So this is 2 ln 1 plus x plus 3. So y triple prime becomes 2 1 plus x. So let's put x becomes 0. So this is 0. X becomes 0. This is 1. Oh. And x becomes 0. Becomes 3. X becomes 0. This is 2. Therefore, y is approximately to the series 0 plus x. Oh, no, I mean, no need to put plus x plus 3 over 2 factorial x squared plus 2 over 3 factorial x to the power of 3, blah, 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 like this. So, yeah, 1 over 3. So this can be the answer. And the next one. Number 16, ascending power of x up to. So this is another like a flexibility. So when you make any calculation near 0, so 0 to pi over 6 could be also near 0. So here, in that case, we can use the Maclaurin series instead of the original function, because Maclaurin series is the approximate model of the original functions near 0. So this is a very good approaches to find the integration between 0 to pi over 6 by using this series. So ln 1 plus sine x, so I need to see it again, ln 1 plus sine x, ln sine x, so let's say sine x plus, minus sine x squared over 2 plus sine x cubed over 3, blah, blah, blah. Oh, to the 4, power of 4. 4 yeah, sine x to the power of 4. Sine x, x minus 3 factorial x cubed plus 1 over 2 x minus squared plus, no, x cubed over 3 factorial, blah, blah, blah. Because when I make it square, I may find the x to the power 4. And here, 1 over 2 x, cube minus 1 over 4 x 4. So now this is x minus x to the power 3 over 6 minus 1 over 2 x minus x cubed over 3 factorial and x minus x cubed over 3 factorial. And we need only until x to the power of 4. So here x squared and like this is negative x to the power of 6 over 4 over 6, but we have 2, so 3. And we don't need any further terms, plus 1 over 2. We have another one here. And when we expand them, 3 of them, we have only x cubed. I mean, we cannot make any, after x cubed, it becomes x to the power of 5. So this is x cubed, and we have nothing to save from the expansion. X cubed over 3 factorial, the same reason, there is only x to the power of 4. Sorry, I mean minus x to the power of 4, blah, blah, blah. We don't need any further. So here, x is only x. And x squared is 1 over 2 x squared. And x cubed, this and this and this is 3 over 6. So 2 over 6, which is 1 over 3 x cubed, plus 1 over 6 minus 1 over 4, 2 over 12, 3 over 12, negative 1 over 12, x to the power of 4 plus blah, blah, blah. So this is this one. So now you can approximate to calculate, integrating of this polynomial up to x to the power of 4 and calculate it with calculator. So that's it. And let's go further. Number 17. You know how to do that. So B. Now this and this is also same. This and this, when we multiply them together, it becomes 0. I mean 1. Power of 0 means 1. So again, this is the same. So 1 plus x squared over 2 plus x cubed over 2 plus blah, blah, blah. And a0 x a1 x a2 x squared a cube x cubed plus, just in case, a4 x4 plus blah, blah, blah becomes 1. So again, when you expand it, you will figure it out step by step, one by one, from a0, next a1, a2, and blah, blah, blah. And like the previous question. And number 19. Okay. So show that x to the power, okay. So now let's find the fourth derivative. Y prime becomes 3 e to the power of 3x plus 3 e to the power of negative 3x. Y double prime 9 e to the power of 3x minus 9 e to the power of negative 3x. Yeah, now we understand that 3 to the power of 3 e to the power of 3x plus negative 3 to the power of 3 e to the power of negative 3x. Am I correct? No? Here, minus. And y to the power of 4 is 3 to the power of 4 e to the power of 3x minus negative 3 to the power of 4 e to the power of negative 4x, but 3 to the power of 4 e to the power of 3x minus, we can say this is also 3 to the power of 4 e to the power of negative 4x. So 81 e to the power of 3x minus e to the power of negative 3x means y. So 81y. So number B, first three non-zero terms of the Maclaurin series for y. So now we already found all of this. X becomes 0, 6. X becomes 0, 0. X becomes 0, 54. X becomes 0, 0. And y, x becomes 0, 0. So 0, 6, 0, 54, and 0. So here, first three non-zero term, means we need to go one more further. Y to the power of 5 is negative 3 to the power of 5, y. No, I'm not correct. So here, 3 to the power of 5, e to the power of 3x, minus negative 3 to the power of 5, e to the power of negative 3x. So here, what is 3 to the power of 5? 9, 81, 2, 4, 3. So 2, 4, 3 times 2, 6, 8, 4. 4, 8, 6. So here, y becomes 6x plus 54 over 3 factorial x to the power of a cube and 486 over 5 factorial x to the power of 5 plus blah blah blah. Simplest form, yeah, you will find it. And C, the expression for the nth non-zero term of the series. Okay, non-zero term. So nth non-zero term means, so this is the first non-zero. So the first non-zero term is the first term is 6x, and second non-zero term is 54 over 3 factorial x to the power of 3. So third non-zero term, 486 to the power of 5 factorial and x to the power of 5. So now actually we know the pattern. So this is 2 times 3 times x. This is 2 times 3 to the power of 3 over 3 factorial x to the power of 3. So here 2 times 3 to the power of 5, 5 factorial of x to the power of 5. So now third number is 5, second number is 3, first number is 1. So 2n minus 1, right? So the nth term is 2 times 3 to the power of 2n minus 1 over 2n minus 1 factorial times x to the power of 2n minus 1. I think this is the one. When you put 3, you will find, yeah. So this is the one.